Continuing our discussion on the security of El Gamal, we just finished up the known ciphertext attack discussion, the most basic kind of attack there is, and we agreed that it has to be secure thanks to the discrete log problem. So recall there are also three more standard message attacks. The next one we would consider would be the next strongest one, which is the known plaintext attack, and that is the subject of Lab 3. So I will let you carry out that analysis. And, you should use this lecture handout as a guide. The sort of arguments I'm making here for known ciphertext or the next discussion on chosen plaintext is kind of the sort of thinking you should be doing, okay? So let's talk about the chosen plaintext attack. This is a good discussion to have. This might be the most important discussion we see because now we learn the really dangerous thing about public key systems and why they are so rare, okay? It's really, really hard to find a good public key system. Here it is. The dangerous thing about public key systems is that Eve, the attacker, can always freely execute chosen plaintext attacks. She can do this all that she wants because your encryption key is actually public and known to everybody in the whole world, okay? So since the way that people encrypt messages to you is known to everybody, Eve can sit there and use that encryption key all day long and encrypt messages with your key. And you won't even know she's doing it because she does not have to have access to your machine to do the encryptions. She can look up the encryption key just like anybody else in the whole world can, and then she can try it on her own machine. So this is dangerous. It requires no interaction with Alice, and it requires no invasion of Alice's network in order to do this. So Alice will have no idea that Eve is sitting there all day long and trying these chosen plaintext attacks. And you should have some appreciation for how dangerous chosen plaintext attacks are because we talked about this in context of the affine cipher and the Hill cipher. Look at your midterm exam and you see how easy it is to break those ciphers using a chosen plaintext attack. Okay, so this is dangerous. All right, chosen plaintext attacks are the most dangerous message attacks out there. And in any public key system, Eve can always do that. And El Gamal is a public key system. So is El Gamal vulnerable to this? Or does it resist them? And amazingly, the answer is yes, it is resistant to these kind of attacks. Let's talk about why. So suppose Eve is going to try a chosen plaintext attack. So she's going to choose her own plaintext. She gets to choose whatever she wants. So she chooses her own message M, and she's going to encrypt it under Alice's public key, right? So Eve is now pretending to be Bob. So she's got to choose her own Y, and she computes B and K and C just like we always do, right? Now, none of these things are secret, right? Usually when Bob is doing this, his Y is a secret, his K is a secret, but now it's not because Eve created them herself, right? And of course, the B and the C are always public. So the only real secret that's out there is Alice's private key X. So the question here is, when Eve can generate her own encryptions, right? Can she somehow use that to get Alice's private decryption key X? Okay, so why can't she do that, right? Well, Eve now has her very own K that she computed, right? She computes this up here, right? She computes this as A to the Y, right? So she creates her own affine key K by A to the Y. And at the same time, Eve knows that that thing K also has to be B to the X, and there is Alice's secret, right? So she knows K because she created it herself. She knows B because she created it herself. And she knows P because it's public. She can look it up in Alice's public key data. And the question, of course, is, knowing K and B and P, can Eve solve for X? And once again, for the third or fourth time, this is a discrete log problem. The answer is no. To solve for X would be to solve that discrete log problem, which no one knows how to do, right? So again, notice how central the discrete log problem is to all of this. So here's the verdict. The security of El Gamal against the standard message attacks we've talked about so far is ensured, it's guaranteed, by the apparent hardness of the discrete log problem. And that is exactly the same thing that happened in Diffie-Hellman. And that can't be surprising since half of El Gamal is Diffie-Hellman. Okay, so once again, it is the discrete log problem that saves the day. As soon as somebody solves the discrete log problem, we are all in a lot of trouble because that will break Diffie-Hellman and that will also break El Gamal instantly. Okay. For the final attack, I want to talk about just a little bit the chosen ciphertext attack. In the interest of time, because we're now remote and we don't have all day, I'm not going to get into it, but it is a really fun thought experiment, though, to sit at home and think about how you would use this. It turns out that there actually is a successful chosen ciphertext attack on Alice's Elgamal scheme. Okay, but the good news is this attack will only reveal one plain text message. It will not give out Alice's secret key X. Basically, it won't give X because there's another discrete log problem at play that you can't solve. However, it is possible to get a message, which is kind of dangerous, right? What if that message was your credit card number, right? They won't get the key, but they will still get your credit card number, right? Now, this isn't a big deal, okay? Because a chosen ciphertext attack actually requires participation by Alice, right? Because Eve is going to choose some ciphertext, and then Eve is going to email Alice and say, hey, Alice, would you please take this ciphertext and decrypt it for me, right? Now, Alice, as a sensible user, would never do that, right? There is no reason for Alice to respond to any message from anybody asking her to do decryptions for them. They don't need Alice to do decryptions for them. Only Alice should be doing her own decryption, and only Alice needs to do her own decryptions. So this kind of attack is easy to avoid, because when Eve says, hey Alice, will you decrypt this message for me? Alice says, no, why in the world would I ever do that for you? Okay, so this is easy to avoid, as any sensible user would never respond to any requests for decryptions, because that decryption request would involve them using their secret key, and they should not be doing that math in front of anybody. So yes, it could be vulnerable. Elgamal could be vulnerable to a chosen ciphertext attack. It would only give away the message, not the key. But if Alice is, being sensible, she would never fall for it anyway. So there's the summary. Elgamal is actually quite secure against all these message attacks. And finally, I'm just going to leave it to you to fill in the gap of the known plain text attack. Let me know when you have questions.